Hello students, welcome to my YouTube channel PKM Classes. Today we will study about the Cramer's rule. What is Cramer's rule? Cramer's rule is a method to solve the equations by taking determinants. So Cramer's rule is a principle. Cramer's rule is a method, but it is a rule to solve the linear equations by taking determinants. Let three equations, Cramer's rule, let three equations a1x plus b1y plus c1z is equal to d1, a2x plus b2y plus c2z is equal to d2, a3x plus b3y plus c3z is equal to d3. Now you take three linear equations where a1, b1, c1, a2, b2, c2, a3, b3, c3 all are real numbers, or that is coefficients of x and y and z. d1, d2, d3 are the value of the equations. Now Cramer's rule is a method or principle to solve the equations by taking determinants. Let a determinant of coefficients a1, a2, a3, b1, b2, b3, c1, c2, c3. Let the value of determinant is equal to delta z. Let the value of determinant of coefficients of x, y, z is equal to delta z. If you multiply column 1 by x, now write a1x, a2x, a3x, b1, b2, b3, c1, c2, c3, that is equal to x into delta. If all the elements of a row or column are multiplied by a factor, then value is multiplied by that factor. If column R is increased by x times, then value is increased by x times. Now we write in case of column 1, we write column 1 plus y times of column 2 plus z times of column 3. Now we increase all the elements of column 1 by y times of column 2 and z times of column 3. We determine the value of a determinant. If the value of a determinant remains same, if columns are increased by corresponding columns with any multiples, if column 1 is increased or decreased by the corresponding columns, the value is not affected. The value is not altered. So we write a c1 in case of c1, a1x, a2x, a3x, we add y times of column 2, b1y, b2y, b3y, and z times of column 3, c1z, c2z, c3z, b1, b2, b3, c1, c2, c3. This value is equal to also x into delta. If all the elements of column 1 are increased by y times column 2, z times column 3, then value of determinant remains same. And this is the value is d1 is given. So this is d1, this is d2, this is d3, b1, b2, b3, c1, c2, c3. That is equal to x delta. So we represent this determinant. Suppose delta x is equal to x into delta. So x is equal to delta x by delta. Similarly, we find y is equal to delta y by delta and z is equal to delta z by delta. In this way, we find the value of x, y and z. By multiplying x and adding y times of column 2, z times of column 3, we find delta x. Similarly, by multiplying y to column 2 and adding x times and z times, we have here d1, d2, d3, that is delta y. Similarly, we have delta z. So now the rule is given as Now the rule of Cramer's rule is given as here delta x into x is equal to delta So del x by you can write x by delta x is equal to 1 by delta y by delta y 1 by delta z by delta z 1 by delta. So we write x by delta x is equal to y by delta y is equal to z by delta z 1 by delta, where delta is not equal to 0. So this is known as Cramer's rule. So Cramer's rule is the method to obtain the solutions, and the rule is x by del x, y by delta y, z by delta z is equal to 1 by delta, where delta is not equal to 0. Now let us take an example to solve the equation by Cramer's rule. The example is 2x plus 3y is equal to 8, x plus y is equal to 3. Now take two equations. The 2x plus 3y is equal to 8, x plus y is equal to 3. Now find delta. Delta is the coefficients of x and y, 2, 3, 1, 1. That is equal to 2 minus 3 minus 1 is not equal to 0. So Cramer's rule is applicable. Now delta x is equal to 8, 3, 3, 1. By replacing coefficients of x by putting the values, we have delta x that is equal to 8 minus 9 minus 1, delta y 2, 1, 8, 3 that is equal to 6 minus 8 minus 2. Using Cramer's rule, we have x by del x is equal to y by del y 1 by delta, where delta is not equal to 0. Hence x is equal to delta x by delta minus 1 by minus 1 1, y is equal to delta y by delta minus 2 by minus 1 2. In this way we find the solution is 1 2. So we get the solution by using Cramer's rule. In this way we find also the solutions of third order equation. In next classes we study the properties of Cramer's rule. Thanks to all.